Cartilage is a connective tissue. The three types of cartilage, along with bone, are collectively called supportive connective tissues. As you can see from this picture, there are a limited number of places where fibrocartilage is located, a limited number of places where elastic cartilage is located. However, hyaline cartilage, which is the most common cartilage in the human body, exists in so many different places, we couldn't even label it all in the picture. For example, there's hyaline cartilage connecting your ribs to your sternum. And we also have hyaline cartilage where two bones meet, such as at the shoulder, knees, elbow, hips. This type of cartilage, hyaline, this type of cartilage that's found at articulations can be called articular cartilage because it's located at an articulation. But hyaline cartilage that makes up your nose is called nasal cartilage because its location. So even though that all of these places have the tissue called hyaline cartilage, we give them a more specific name based on their location. Cartilage is neither innervated nor vascularized, and this is why we're able to pierce ears, noses, and other flaps of cartilage. The piercings do not heal, and the holes remain open. I always have students say to me, yeah, but the holes heal. No, they don't. Actually, the skin heals over the hole in the cartilage, making the piercing itself, but the cartilage allows the skin to do that. Because once you've pierced that cartilage, it now has a permanent hole in it, and it will never heal that hole. The prefix hya comes from a root Latin word that means glassy. And this means that the chondrocytes, which are the most common cells in cartilage, and the matrix has a glassy appearance. We know that the matrix of any connective tissue is the ground substance and the fibers that surround all of the specialized cells, kind of like a gelatin with fruits in it. In these two pictures, the chondrocytes, they look like ovals with an eye on them. That's what I think they look like, even in both pictures. Hey, look at this one here. It could be an eye. But between all of the chondrocytes, between them is the matrix. And it has collagen fibers in it, but there are so few of them that the matrix, when stained, it takes on this glassy appearance, as you can see in the picture on the right. Elastic cartilage is found only in your ear and your epiglottis, which is the flap that covers your trachea when you're swallowing food down your throat to your esophagus. Elastic cartilage is essentially just hyaline cartilage with a whole lot of elastic fibers in the matrix. And you can see that I have represented this by drawing a whole bunch of squiggly lines in the drawing on the left. But you can also see that in the picture, the real picture on the right, there does seem to be what looks like scratches or lines in the matrix between the chondrocytes. These really darkly stained scratches, those are the elastin fibers caught in the matrix, making this elastic cartilage. Fibrocartilage can be found at a variety of different articulations, especially those where bone comes into direct contact with other bone and weight bearing, so low on the body. Students can usually connect to fibrocartilage being in the meniscus or menisci of a knee, and these here, that's a meniscus, and that is also a meniscus. A meniscus, it's a pad that reduces the shock of the superior-inferior forces of gravity. At the knee, there is a lateral meniscus and a medial meniscus, both mediating the connection of the distal condyles of the femur, which are these, and the proximal condyles of the tibia, which are those. The other place that you may be familiar with fibrocartilage is the discs that are between the individual vertebra in your spine. The picture in the middle here, it's a top-down picture where we're looking superiorly down at a transverse cut of the spinal cord. So here's you, that's your spinal cord, and here's your arms and legs. And we are looking at a transverse cut of your spinal cord. This is posterior. The big spine, the big thing comes off posterior, and this is anterior. The yellow structure in the center is the spinal cord itself, with two nerves coming off the sides. The blue oval is the fibrocartilage disc that protects the impact between the vertebra below it and the vertebra above it. People with lower back problems can have various stages of bulging or herniated discs. These are discs in which the internal blue portion kind of forms this like pressure bubble that just comes off, like everything kind of goes like that and forms this pressure bubble that comes off of the disc itself. Usually comes off on the posterior side, pushing on the spinal cord or those nerves. It should be noted that everybody, every human, has degenerative disc disease. It's just a matter of how fast your degeneration is happening. Fibrocartilage is very difficult to stain because the collagen fibers and their orientation require a different stain than the chondrocytes themselves. So in order to be successful, the cytoplasm of each chondrocyte has to kind of be removed to make any sense. And that's why in this histological picture here, you can see a few chondrocytes by their very darkly stained nucleus around them. So like this is a chondrocyte, there's one right there. But you can see around them, there's just like nothing around the nucleus. It's just a clear area because the cytoplasm has been removed. I also usually have students ask me questions like, how can you slow down the degeneration of your discs? And I'm so sorry that the answer to that is hydrate more. The more your discs are dehydrated, the more injury that they'll incur. So it always comes back to water, doesn't it?